In this lesson, I will explain to you the concepts of rational and irrational numbers. So first we will discuss the rational numbers. Rational numbers can be written as P over Q. What does it mean? It means that you can write down as a fraction. Suppose 4 divided by 6, 1 divided by 10 and so on. So you can write down rational numbers in the form of P over Q, where P and Q are integers. Right? So see, this is integers 4, 6, 1, 10 and Q is not 0. Right? P over Q. So this Q denominator should never be 0. This is the definition of a rational numbers, that you can write down rational numbers in the form of fraction where P and Q are integers and Q is not 0. When written as decimal, now second part is also very important, that when we write the rational numbers in the form of decimals, so rational numbers terminate or repeat. Right? So this one I will explain to you the next slide. What does it mean? So the rational numbers are denoted by Q and we write it P divided by Q. Whatever the definition I have explained here, in actual form you have to write down like this: P over Q, and this line represents while P Q belongs to Z, and Z is the integers 1 2 3 4, and this sign represents and Q is not equal to 0. Right, the same definition is here. So rational numbers P over Q, this is the general formula. You can write down A or B or whatever you want. So P over Q, where P and Q are integers and Q is not equal to 0. So how you read this? P divided by Q, while P and Q belongs to Z, Z is the integers and Q is not equal to 0. Right, now we will discuss what is the meaning of terminate or repeat, because when we write the rational numbers in decimals, rational numbers terminate or repeat. So there are two types of representation of our rational numbers. One is the terminating and other is the recurring or repeating. Right, so terminating decimal fraction. Terminating, the decimal fraction in which there are finite number of digits in its decimal part is called a terminating decimal fraction. See, suppose 2 divided by 5. When we divide 2 by 5, we will get 0.4. So 0.4 is the finite number. We can count that after decimal there is only 1, 0.4. 3 divided by 8, point equal to 0.375. Again it is finite. We can count 0.375. Right? So I told you that rational numbers in the decimal form may be terminating. So this is the example of terminating. You can count after decimal. Or reoccurring. Reoccurring means the decimal fraction in which some digits are repeated again and again in the same order in its decimal part is called the non-terminating decimal fractions. Suppose 2 divided by 9. When we divide 2 by 9, we get 0.2222 and it is never ending, non-terminating or repeating. Right? 4 divided by 11, 0.363636, never ending. So rational numbers are non-terminating or reoccurring. Now we will discuss irrational number. The numbers which cannot be expressed as a quotient of integers are called irrational numbers. Means you cannot not write down as a fraction. Irrational number you cannot not write down as a fraction. It is denoted by Q dash. Irrational numbers cannot be written as P over Q, or you can write down A over B or C over D, whatever you want. And it is denoted by Q dash. So how we read it? X while. This line represents while x is not equal to P over Q. It means P you cannot write down in the form of fraction P and Q. While P and Q belongs to Z, Z is the integer and Q is not equal to 0. So all the numbers in the radical under root 2, under root 3, under root 6, e, pi, these are the examples of irrational number. You cannot write down as a fraction. Right here, irrational numbers, decimal representations of for irrational numbers are neither terminating nor repeating in blocks. But in the case of rational numbers, it was terminating and repeating. Irrational numbers neither terminating nor repeating in blocks, just like pi. The value of pi is 3.141592c, never ending, neither terminating nor repeating. Under root 2, 1.41421356, neither terminating nor repeating. Right? So in this lesson, you have learned the concept of rational or irrational numbers. If you have any question, you can write down in the comment section. Please do not forget to subscribe to my channel on YouTube, Saima Academy, and thank you so much.